Hello everyone, my name is Corbin Gustafson and this is my project submission for Lab 1 for Aerospace experiments. I hope this will be used as a reference for future students who are confused on ANSYS because I know I was. Here we have the workbench open. You can drag in anything you want, a system for Fluent. I made a separate geometry and then you just connect that to your Fluent geometry and it will use whatever you put here and here. But for the purpose of this video, I already have one. So I'm just going to go ahead and open this geometry. All right, here we are at the design modeler for ANSYS. Similar to SOLIDWORKS, it's just a CAD software. It's worse than other CAD softwares, but whatever. All right, so inside of here we have the three planes. I'm just going to go to my first sketch. So if we go in here, the way my group did it was we took measurements along the diameter of the wind tunnel and we tried to get those as close to equal distance as possible. And so what I did was I plotted these heights over the time of this and it got us a nice curve right here. This is the test section and this is the diffuser section of the wind tunnel. Got all these measurements in class. And then once you have this sketch, I made a separate plane like with an outline of that previous sketch, and then I traced it along the outside. So now I have a sketch that has the geometry fully defined, and then I have a sketch that I could just use to make one part, one surface body, just like that. And the way that you do that from concepts, surface from sketches, and then you say, okay, I want this, I want sketch 7. And then generate. And that would give you a surface body. Okay, now we're going to move on to the next section. So anytime you change anything in the geometry, what you're going to want to do is you're going to want to update everything downstream from that. So right now we're just updating the mesh. Okay, so now we got this green check mark from our mesh, so we know it's ready to be opened. So we're just going to go ahead and go into edit. Okay, so when your model opens up into edit, it's going to look something like this. What you're going to want to do is you're going to want to go to here. Let's go ahead and delete these. Okay, so you're going to want to go into your mesh, and the first thing you want to do is you're going to define your element size. For the project, I did 0.003. And then go back here, click on mesh. You're going to want to go into method. Click on the geometry. For the purpose of this experiment, I use triangles. Other geometries may be good for other things, but for this one, what I've seen is triangles mostly. So I just clicked on triangles there, and then you're going to want to generate that mesh. So now, for the next step, you're going to want to name your different sections. So we can go right here. You click on up here where it says select edge. Click on the edge that you want to select. Right click and create name section. So because the velocity is going this way, you're going to want to name this velocity inlet. And then go ahead and click on the other side. Right click, create name section. And this one is going to be pressure outlet. And then go ahead and click control and then click down on every piece of your wall. What naming them is going to allow the system to do is to predefine boundary conditions before you get into the next step. So you can just call that walls. Right, and so now we have velocity inlet, pressure outlet, and walls. And we have a good mesh, so that's all you need to do for the meshing tool. Go ahead and close that out. Okay, now you're going to want to update your setup. Okay, now that it's updated, you're going to want to go into Edit, and you should get a window that pops up right here. It automatically knows it's in 2 dimensions, and it's going to ask you how many solver processes you want. I chose 6. You can choose whatever number you want, however many cores your CPU has, or however many cores you want to allocate to ANSYS. So go ahead and click Start. All right, so here we are loaded into the actual Fluent solver. So some important things to be mindful of. So when you go into models, you're going to want to make sure your energy equation is on, and then let's go into the viscous part. Have K epsilon selected, and then I decided to turn on enhanced wall treatment with both pressure gradient effects and thermal effects on. Okay, so make sure both of those are on the energy equation in the viscous model. Under materials, you should just have air and aluminum. Now let's go into the boundary conditions. So under boundary conditions, inlet, velocity inlet, this is where you're actually going to be inserting your data from that you collected during class. So the data that you collected during class was velocity in the wind tunnel. To get the velocity in the inlet, we did height ratios for the wind tunnel to inlet. We didn't do area because this is 2 dimensional. We did height ratios. So for the 10 hertz, or I guess the video is supposed to be 30 hertz. So for the 30 hertz, we got 2 meters per second as the inlet velocity. So let's go ahead and apply that. That's all you need to change for boundary conditions. Now let's go down to. After that, you should just be ready to initialize. Your gauge pressure on the outlet pressure will be 0. It's not actually 0, but for the purpose of this experiment, we're saying that when it enters the atmosphere, the pressure immediately goes to atmosphere. Okay, so let's go ahead and initialize that. And then after you initialize, you're going to want to run the calculation. I set my number of iterations to 250. It doesn't get that high. If it does, something's wrong. Let's go ahead and calculate that. All right, and we're back, and the calculation was completed. So here we go. Now we're going to want to go into, let's go into graphics first. So under graphics, under contours, you can see that I've already created some. Let's go into the static pressure one. So I've got walls, velocity inlet, pressure outlet, and my interior surface body. And so if you press compute and then save and display that, there you go. Okay, now we can go into dynamic pressure, and for the dynamic pressure, you'd expect to see the opposite, and you do, right? Lowest pressure here, highest pressure here, somewhere in the middle, right around here. You're also going to want to find, this one should be velocity, and compute, display that. Right, so this makes sense. Lowest here, highest here, somewhere in the middle down here. Matches up very well with our dynamic pressure plot. Okay, and now you might be wondering, what about the X and Y plots? So let's go down here. So let's go to dynamic pressure first. So the first thing that you're going to want to do is you need to make a center line, right? So that center line, you make it like this. You go to new surface, line or rake, and then you can put whatever numbers you want in here as long as it's outside at least of the range of your entire system. So, and then you call that center line. I already have a center line, so I'll call it center line 1. Okay, create that, close it out. So now we got center line 1, and you're plotting dynamic pressure over the center line. So the pressure, dynamic pressure, let's go ahead and save that plot. And here you can see the dynamic pressure over the entire x-axis of that body. Okay, now let's try this with one more thing. Let's go velocity. See, looks very similar to the dynamic pressure line, and that makes sense. But now if we go and look at the static pressure, we would see something different. Again, center line, pressure, static pressure, then I named it to be that. Let's go ahead and save that plot. And that makes sense. We expect it to be the opposite of the dynamic pressure plot. Okay, and now we're back, and now we're looking at how to do the actual vertical line section. So to do vertical line, what I did was I went here and I typed in, okay, so you imagine that on your vertical line, I have my entire geometry at the test section, and the test section is centered around the origin. So the x-axis of the middle of that test section is going to be 0. Now the y-axis, similar to the way we did the center line, doesn't matter how far. And if you notice, it's in meters, so I just did -1 and 1 because the entire test section should only be about 16 centimeters tall, give or take. So I create that line, vertical line. Go ahead and close that out. We have vertical line right here. And then let's do velocity. So we have the velocity magnitude plotted along the vertical line. Let's go ahead and save that plot. And here we go. That you can see the boundary conditions as you approach the walls of the testing chamber, as well as this stable, not turbulent flow. And that wraps up the ANSYS section of Lab 1 for aerospace experiments. Thank you.